Well, of all the assignments you guys are going to have to do, this is probably going to be the hardest one. So you want to make sure that you, we're going to do more, we'll probably do about 3 problems. Hopefully by the end of the 3 problems you will kind of see the process and how to do things. Step 1, we're going to write down our rational expression right here. We've got to write this down nice and neat. So I'm going to write 6x cubed minus 10x squared all over 3x cubed minus 2x squared minus 5x. So there's going to be 2 things that we need to do. Number 1, we're going to write the simplified expression right here. The next thing, we need to find all the values of x that make the expression undefined. Once again, those values are whatever number you can plug in here to make this denominator equal to 0. So, first thing I'm going to do is I'm going to factor out common factors out of the numerator and the denominator. So I'm going to go ahead and highlight the numerator. Highlight that in blue. And then I'll highlight the denominator in red. Now I'm going to go over these a little bit differently than the previous videos. I'm not going to just break it down into its prime factors. I'm just going to let you know what you can bring out of it as far as what would be the greatest common factor. The greatest common factor between a 6 and a 10 is 2. So I'm going to factor out a 2. The greatest common factor out of an x cubed and an x squared is x squared. So that's the greatest common factor that I can factor out of the numerator. When I factor that out, I'm left with a 3, because 2 times 3 is 6. I'm also left with an x, because x squared times x is x cubed. Here I'm going to put minus a 5. It's not a very good 5. I'll try to draw a better 5 here. That's a little bit better, okay? Because 2x squared times negative 5 is negative 10x squared. So that's this right here. What do we call that? We call that the greatest common factor. Alright, that's the greatest common factor. So, now I'm going to factor out the only number that I can, the only variable I can factor out is an x. So in the denominator, I'm going to factor out an x, and here's what I'm left with. I'm left with a 3x squared minus a 2x minus a 5. If you multiply x and distribute it all the way into this trinomial, you get this trinomial right here. Okay, so that's step 1, is to factor out the greatest common factor. Now, the numerator is done. We can't factor anything more out of the numerator. But the denominator, I can factor it more. Now, we went over in the last video, I'm just going to do a quick little example, x squared minus x minus 12. Like if I wanted to factor this, is very, very, very easy when the number in front of it is a 1. If the number in front of this x squared is a 1, you can easily factor it, if it's factorable. You're looking for 2 numbers, even though you can't see it, you're looking for 2 numbers that add up to equal a negative 1. So even though you can't see it, there's a negative 1 right there. That's negative 1x. And you're looking for 2 numbers that multiply together to equal a negative 12. Now those are pretty easy to find. We can pretty much see that a negative 4 plus a 3 is a negative 1, and negative 4 times a 3 is a negative 12. So we could factor this to x minus 4 and x plus 3 and be done. Remember, this is just an example. This has nothing to do with our particular problem. The problem we have has a 3x squared, so we can't do this method that we just did in the last video. What we have to do is what I like to do is I like to just kind of test out the FOIL method. So we're going to put a 3. We know this is going to be a 3x and this is going to be an x. Now, if you haven't done the FOIL method in a while, all right, what we're going to do is I'm going to practice right now. I'm going to practice multiplying 2 binomials together. All right, so I'm going to put 3x minus 5 times an x plus 1. All right, 3x minus 5 times an x plus 1. Now, if we were to do this the FOIL method way, first, outside, inside, last. If we were to multiply these 2 binomials together, here's what would have to happen. We're going to take the 3x, all right, and we're going to multiply it to this x right here. That's going to be our first terms, all right, first terms. So F stands for first. And our first terms that we would multiply are 3x times x, which would give us 3x squared. Then we would have to multiply the 3x all the way out here to the outer terms. Alright, so this right here, this is the first term. This is, I'll do a capital F here. These are the first terms. These are the outside terms. So O stands for the outer terms, or the outside terms. And those terms are 3x times 1. And 3x times 1 is 3x. Then I'd have to change things, and I have to go everything to the inside. Alright? So the inside terms are just right here. Alright, that's the inside term with capital I. Also known as the inner products. And our inner products are negative 5 times an x. And negative 5 times an x is negative 5x. And then our last terms are from here over here. These are our last terms, the L. And our last terms are negative 5 times 1, which makes it equal to negative 5. When you're doing this, the most important part is the sum of the outer and the inner terms. Alright? The O and the I. Oi. Because when you add those together, you get that negative 2x. So that what's the final product? The final product is 3x squared minus 2x minus a 5. So what I want you to understand, if you check this out, that's right there. There's our product, 3x squared minus 2x minus 5. So what would the factors be for our problem? The factors are 3x minus 5 and x plus 1. Well, when you're trying to figure out how to factor a trinomial, there's another way you could also do it using the array method, where you kind of just set up an array. And I'll do that as well and see if this will make a little bit more sense, that you could also use to figure out your products. Or your factors, that is. Okay. So, whenever you are trying to figure out the factors to 3x squared minus 2x minus 5, you know you have to have a 3x multiplied to an x. Alright? But what you have to figure out is you got to figure out, if you know you've got 3x squared in one corner, and you know you have a negative 5 at the end, you have to figure out what are the other two numbers that have to go right in here. Alright, now our numbers were a 1 and a negative 5. When you do it this way, you're testing things out. 3x times 1 is 3x, and negative 5 times x is negative 5x, and negative 5 times 1 is negative 5. But the most important part is adding those together. Those two together, added together, have to equal this middle term. If you can't, and so that's how you're going to have to do a little bit of guessing and checking if you aren't really good with the FOIL method. So, what are my suggestion? When you get something like this, we're going to do more than one problem. Always look at the outer products and the inner products. So always look at the outer and the inner and see if it gets you to this negative 2x. So that's what I always do when I'm visualizing it. I'm like, okay, 3x times 1 is 3x. Minus 5x, that gets me negative 2x. I know I found the correct factors. Alright, so now that we have the correct factors, what we're going to do is we're going to cancel out some common factors, and we're going to figure out the numbers that make everything equal to 0. So what I'm going to do is I'm going to rewrite this nice and neat right over here. I'm going to put 2x squared, 3x minus 5 all over my factors that I found. Okay, so everything's nice and neat. Now, we're not totally done. This isn't totally simplified. You can see these are going to cancel out, okay? But we got to figure out the numbers that make this expression undefined. So, like, what values of x would I plug in right here? This one's easy. I could plug in a 0, and everything right now would make everything equal to 0, because 0 times anything is 0. This one's a little bit trickier. It's going to be pretty easy. It's just going to be positive 5 over 3, and I'll show you how to solve for that here in just a second. And then right here, the number that we'd plug in here is just a negative 1. So the three answers that will make the expression undefined is x equals 0, x equals 5/3, and x equals negative 1. Now the shortcut is just take the negative version of this number over this number. So the negative version of a negative 5 is a positive 5 over 3. But if that doesn't make sense, you can just set 3x minus 5 equal to 0, and then just quickly solve for x by adding a 5 to this side and adding a 5 to this side. Alright, you're left with 3x equals 5, and then you just divide both sides by 3, and x equals 5/3. So that's probably the most common way that's taught, is just set this equal to 0, set this equal to 0, and set that equal to 0. Okay, so these are your answers that make it undefined. Now that we have all of our answers that make the expression undefined, now we can go about simplifying the rest of it. So the rest of it, what's the rest thing we got to do? Get rid of those. Also, x goes into x squared just one time. So if you're wondering what the heck I just did there, if you have x squared divided by an x, that means you have x times x divided by x. These cancel out, and you're just left with one x right there. So here's my final simplified answer. I have 2x up there in the numerator. That's it. And the denominator, those are canceled, so I'm just left with x plus 1. And that's what I'm going to write as my simplified expression. And that is in expanded form. Okay? So I'm going to write 2x over x plus 1. And then I am also going to select the three values. Let's see, here we go. My three values were 0, 5/3, and negative 1. Those are my three values, negative 1, 5/3, and 0. And then right here, I'm going to make the little fraction bar. I'm going to type in a 2 and an x, and then in the denominator, x plus 1. Alright, let's double check my work. These that didn't cancel out, those canceled out, those canceled out, and I feel pretty confident that I'm going to get the right answer. And good job. Alright, I realize that took a little bit of time. Let's go on to the next question. Here we go. First thing I'm going to do is I'm going to rewrite it. 3z to the power of 11 plus 3z to the power of 5 all over z to the power of 12 plus 4c to the power of 6 plus 3. Okay. We're going to have to make sure our answer is in expanded form. We've got to find all the values that make this expression undefined. So, first thing I'm going to do is I am going to factor out the greatest common factor out of the numerator. So I'm going to highlight the numerator once again in blue. Highlight the denominator, our trinomial down there in red. Then you got to ask yourself, what's the greatest common factor that goes into a 3z to the power of 11 and 3z to the power of 5? Well, I know a 3 goes into both of them, And the greatest exponent that's common to both is z to the power of 5. So what does that leave me with? Well, if you remember, it's called the product property for exponents. If I have, let's say, x to the power of m times x to the power of n, I am allowed to simply add the exponents together. So basically, what number plus 5 gets me to an 11? That's z to the power of 6. So when I'm multiplying exponents, all you gotta do is just add those exponents together, and that gets you that's called the product property. All right. Now, the next thing we're going to do is we're just going to put plus 1, because 3z to the power of 5 times 1 is 3z to the power of 5, and we're done with the numerator. All right, now we're going to look at the denominator. Now, the denominator kind of looks intimidating, but really it's going to be pretty basic. If I said, what is z squared plus 4z plus 3? I think most of you be able to factor it. You're looking for two numbers that add up to 4, the middle coefficient, and you're looking for two numbers that multiply together to equal 3. Well, the only factors of 3 are 1 and 3, and 1 plus 3 is 4. So you put z's plus 1 and z plus 3, and those would be the two binomials that multiply together, if you use the FOIL method, to equal this trinomial. So we're going to use the exact same concept. The only thing that's different is one thing. Instead of z times z, which is z squared, we're going to put z to the 6 to the power of 6 and z to the power of 6. But we're still going to use the same coefficients, a 1 and a 3. All right. If you use the FOIL method, all right, or you do the array method, okay, I'll go ahead and do the array method one more time because I know some students like this method more than the FOIL method. If I said z to the power of 6 plus 1, and then I said z to the power of 6 plus 3, I have 3 right there. Z to the power of 6 times z to the power of 6 is z to the power of 12, because 6 plus 6 is 12 using the product property. 3 times z to the power of 6 is 3 times z to the power of 6. And z to the power of 6 times 1 is itself. And then 3 times 1 is 3. If you add these together, you can add 3z to the power of 6 and z to the power of 6, and that gives you a total of 4z to the power of 6. So that's another way of doing it, just using the array method here. Now, we're almost done. So if you take a look at this, after we have everything nice and factored, now we just have to figure out, are there any numbers that we could plug in here to make this equal to 0? Now here is an important thing I'm going to highlight right here with this orange. If this is an even power and this is an even power, that means there's no number that you could plug in there to make it equal to a -1. So there's nothing you can do about it. Because technically, what's the only thing that added to a 1 that makes this expression equal to 0? A -1. Well, there's no number that you can plug in there to make it equal to a -1. And there's no number you can plug in here to make it equal to a -3. So there's going to be no solution, not no solution, there's going to be no value for z that you can plug into the denominator to make it equal to a 0. So we're just going to, now that will work if and only if this power is even and this power is even. Now we can cancel these out. Like these will obviously be, these are the same factor, so they can be canceled out. So our final answer in simplified expanded form is going to be 3z to the power of 5 over z to the power of 6 plus 3. And that's what I'm going to write into the Khan Academy. All right, so remember that. We're going to go right over here. I'm going to type it in. So the first thing it says, none of the above. None of these will work because we have an even power in the denominator. Over here, I am going to write 3z to the power of, was it 5? I believe so. 3z to the power of 5, and then z to the power of 6 plus 3. All right. Z power of 6 plus, oh, not that, that's not what I want. Right arrow, okay, here we go. Plus 3, almost made a mistake there. Alright, z to the power of 6 plus 3, none of the above. I'm good to go. Alright, now once again, if you happen to mess up, you can go here and see step-by-step solution. Alright, and you can kind of see what I was talking about. In fact, there's no number you could plug in here to make it equal to 0. No number you could plug in here to make it equal to 0. Alright, so you can kind of see there's where we canceled those out. Alright, and you can move on to the next question. But make sure you check, if you mess up, make sure you see that step-by-step solution so you can learn from it. Alright, and we'll do our last, this will be the last problem, okay? It says simplify the following rational expression and express it in an expanded form. So here we go. Right now, I'm going to take 10x plus 5z divided by 14x squared plus 5xz minus z squared. And we're going to go ahead and show you guys how to factor these. So, like I've done before, what I'm going to do is I'm going to highlight the numerator in blue. We'll do that first. And then we will highlight the denominator in red and do that last. Alright, let's go ahead and factor this. Now, the greatest common factor between a 10 and a 5 is just 5. So I'm going to factor out of 5. If I divide 10 by 5, I'm left with 2. And the x is still there. And if I divide 5z by 5, I'm just left with a z right there. Now, I've done enough math problems to know that there's most likely, this factor right here will be inside of this expression, okay? So when you're factoring it, you factor something out. See if this possibly might be a part of this, because they're wanting you to simplify stuff. Now, the factors of 14 are 14 times 1 and 7 times 2. Being that we have a 2 here, I'm going to start with a 7 and a 2. And I'm just going to test the theory that this is going to be a factor, and I'm going to put plus a z. And if this is plus a z, then over here I'm going to have to put minus a z to see if that actually ends up becoming the factor. Now, from the last problem, or maybe I think it was the last problem, we want to focus on the outer products and the inner products right here. The outer products and the inner products. And that'll let us know if we got everything factored correctly. Alright? So, what is the outer product? The outer product is 7xz. The inner product is minus 2xz. When you add those together, what is 7 minus 2? 7 minus 2 is 5xz. Which makes this really nice, because that's what we needed to have in the middle. Now, what does that mean? That means we actually factored it correctly. So here's our final answer in factored form before we simplify everything at the very end. Let's put everything in blue. So one of the factors was 7x minus z, and the other factor was 2x plus z. Alright, now, what ends up canceling out? Check this out. That factor cancels out that factor. So what do we finally have left? We have 5 over 7x minus a z. And this is going to be our final simplified answer that I'm going to type in. And now that's already in expanded form. I didn't have to multiply anything out. Everything's already totally multiplied out. There's no parentheses. Everything's good to go. And so when it says everything needs to be in expanded form, it means that if you have to use the distributive property, you better use it. So I'm just going to type in 5 over 7x minus t. We'll call it a day. Alright. 5 over, not 7x minus 2, sorry. That would have been bad. 7x minus z, not a 2. 7x minus z, 5 over 7x minus z. Just making sure I double check it. I always hate it when I get a problem wrong, so we just want to make sure we double check it. Alright, you know what? Since that last problem went pretty quick, we'll do one more. Then we'll call it a day. Now, if you want to stop the video, you're more than welcome to. You don't even have to listen to this video. Oh, that's not the right answer. Or maybe it is, we don't know. Okay, so we have one more problem to do. We have 25z squared minus 80z plus 64. Looks like we got a sum of squares in the numerator. Looks like we're going to end up having a difference of squares in the denominator. Very nice. Alright. Like, I have no idea what you're talking about, but we'll talk about the sum of squares, how to recognize when you have a sum of squares and when you have a difference of squares. This is going to end up being the numerator right there, ends up becoming a sum of squares. And once we factor out a special little number out of the denominator, alright, we're going to find that this is going to be what's called a difference of squares. So I'm going to go ahead and label this. Ready? I'm going to label this is called a sum of squares. Now, the reason why I know it's going to be a sum of squares is I know the square root of 25 is 5 and the square root of 64 is 8. So I already know what this factor is going to look like. Just because when you do it so many times, you can kind of recognize them. Alright, but I know some of you, you're like, how am I going to recognize it? First thing, check if that's a perfect square and that's a perfect square. If you're wondering what perfect squares are, alright, I'll just write a few. If you already know this, you just fast forward through this part. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on and so forth. So I know 5 squared is 25, and I know 8 squared is 64, so automatically that gives me a clue that I'm dealing with what's called the sum of squares. Alright, so what does that mean for us? That means this is going to be a 5 and a z, and this is going to be a 5 and a z. And the square root of 64 is 8, so I know I'm going to have an 8 here and an 8 here. But if that says minus in the middle, that means both of these have to be negative. Alright, because you need to have a negative middle coefficient and a positive last coefficient. Well, a negative 8 times a negative 8 equals a positive 64. Now, I'm quickly going to show you that these are the factors for those of you who are never been taught factoring before Algebra 2, which is depressing. Alright, so here we go. I'm going to put a 5z. I'm going to put a negative 8. And then I'm going to put a 5z and a negative 8. We multiply these together, you get 25z squared. 5z times negative 8 is negative 40z. Negative 8 times 5z is another negative 40z. And negative 8 times negative 8 is a positive 64. Well, let me tell you something. These, I'll do it in green, negative 40z plus another negative 40z. Check it out. Gets us this negative 80z in the middle. Okay, so that's how I knew it was going to be a sum of squares. So that's everything completely factored. Now this one's actually, just remember, you could also do the FOIL method that we've done before. And I think we're going to go back to the FOIL method. First outside, inside, last. I did something over here with the FOIL method. Oh, here we go. That's the outer. There we go. There's the FOIL method. Here's the FOIL method right here, where you do the first, the outer, the inner, and the last. The first products, the outer products, the inner products, and the last products, where you're trying to find the factors. Okay, now this is going to end up being what's called a difference of squares. And you'll know what a difference of squares is if you watch the previous videos, because we covered difference of squares. But it's going to be important that I got to first factor out a common factor out of both of those. So actually the factor I'm going to factor out is a 3. I'm going to factor out a 3, and then it's going to be a little bit easier for us to simplify this. Now, how do you know something's divisible by 3? Well, there's a cool little rule. If you add all of the numbers up, 1 plus 9, which is 10, plus 2, which is 12. 12 is a multiple of 3, so therefore I know it's divisible by 3. Just like 7 plus 5 is 12, which is a multiple of 3, so it's divisible by 3. So the rule is, if all of the numbers added up are a multiple of 3, you can divide it by 3. So let's check this out. 2 plus 5 is 7. So, no, 3 does not go into 25, because 7 is not a multiple of 3. 8 plus 0 is 8. Well, 8 is also not a multiple of 3, so 3 does not go into 80. 6 plus 4, 10. 3 does not go into 10. Okay? So, here, 3 does go into 12, and 3 also goes into 12. So, right now, check it out. If I do 192 divided by 3, voila, we get a 64. Ah, that's going to be nice. So we have 64 minus, and 75 divided by 3 will be 25. I'm going to put z squared. Now, this is a perfect square. This is a perfect square. Look what a difference of squares factors to. It factors to an 8 plus 5z and an 8 minus 5z. So now I'm going to write these factors right now. Okay, these factors I'm going to write right over here. 3. I'm going to write an 8 plus 5z and an 8 minus 5z. And we have a very important rule here. This is going to be like super important. Hopefully you watch the very end of this video because this is going to be important. If I have a minus b and I have b minus a, these will always end up equaling a negative 1 as long as b minus a doesn't equal 0. Okay? All right, so what does that mean? How does that work? Well, check this out. Let's just give me two random numbers that, all right, we're going to put 4 and a 3, and then I'll put a 3 and a 4. Well, 4 minus 3 is 1, and 3 minus 4 is negative 1. 1 divided by negative 1 is also negative 1. So this is the rule I want you guys to put into your journal. What does that mean for us, for this particular problem? Well, check this out. We have a 5z minus 8, but that's being divided by an 8 minus 5z, and it follows this pattern. So I can actually say, you know what, I'm going to cancel you guys out, but it's not going to equal a 1, it's going to equal a negative 1. Alright, so I'm going to put a little star next to this and make sure you know that this will always work. So I am going to cancel this with this, and let's see what we have left for our final answer. So this right here will end up becoming our final answer, but we got to be very, 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 very careful because it says it needs to be in expanded form. So I'm gonna write our final answer in expanded form, and then we'll type it in. So what do we have left? We have a 5z minus 8 over. Now I'm going to multiply 3 times 8, and I'm going to get 24. And then 3 times 5z is a total of 15z. But I'm going to write my final answer. I like to put the variables up front and the constants in the back. So I'm going to write it as 15z plus 24. And that right there, that is what we call expanded form. So I'm going to write it in this form. There's no other factors that I can factor out that's common to both the numerator or the denominator. All right. Now, we also have to find, all right, an expression that makes everything undefined. Okay. So, forgot to do that, so I apologize. So, what number would we have to basically, I'm going to rewrite it in factored form in just a second. I'm going to write it in factored form. Alright, so I've kind of rewritten it in factored form, and then we're also going to find our final the numbers that make it undefined. So basically we're looking for like what number do I need to plug in here and what number would I need to plug in here to make it equal to 0. So once again, all you got to do is set it equal to 0. So here I'm going to take away an 8. I'm going to take away an 8. I get 5z equals negative 8. Divide both sides by 5. And I get z equals negative 8 fifths. So that's one of my answers. Over here, I'm actually going to add 5z to this side. I'm going to add 5z to this side. That zeroes out. I'm left with 8 equals 5z. Divide both sides by 5. And I get z equals 8 over 5. And that's going to be my other answer. So the values that make this equal to 0 in the denominator is going to be negative 8 fifths and positive 8 fifths. Alright, and then my final simplified expression is going to be this right here. Okay, this is going to be my final simplified answer. The only thing that I want to make sure that you do that I forgot to say earlier right here is this is my final simplified answer, but I have to make it a negative. So I have to put a negative out in front because I forgot right here it says 5z minus 8 divided by 8 minus 5z equals a negative 1. I forgot to apply that negative. So your final simplified answer that you would end up typing in right here ends up becoming, I'll just write it right here, we have negative, then this becomes 5z minus 8 all over 15z plus 24. Plus 24. With the negative just right next to that fraction. Right next to the fraction bar. Okay? And the two numbers that I would select that would make my answers undefined are B and C. Okay? I hope this was helpful. You have a good day.